Hey everyone, welcome back. We're going to look at another example on how to use SOHCAHTOA to solve for a right triangle. So I went ahead and copied our equations up here. And then we're going to use that same triangle from our previous example, just so we can show how to solve for different things. And in this example, we are given our opposite side and our hypotenuse side up here, and we don't know our adjacent side. And this time we do not know our angle. So our first step, we confirm, okay, yes, this is a right triangle. We have that symbol here. And then next we want to label all of our sides to make this easier. So we have our adjacent side. I'll go ahead and put A down here for short. And then next we have our hypotenuse side, which is the longest side of our triangle. So I'll label this H. And then that leaves this to be our opposite side. And that's there, pretending that you're shining that flashlight and that beam on a wall across the room that's opposite of you. So that's going to be your O opposite. All right, so we got our sides labeled. What we need to do is solve for this angle here first. And to do that, we know our O and we know our H. We're not going to worry about this just yet until we get this angle. So I'm going to use the equation. I'm going to use our SO equation to solve for our angle, because we got our O and our H here. That way, our only unknown value is our angle that we need to solve for. So I'm going to go ahead and write that down. So we got sine, and then our unknown value here of theta. And then up here we got our opposite first, which is 3, divided by our hypotenuse side, which is 6. And I'm going to go ahead and replace this with 1/2 to make it just a little bit easier and less messy. So I'll rewrite this as sine theta is equal to our 0.5. And now we need to find a way to get our theta by itself, which means we have to break this apart and move the sine over here. So the problem with that is when you do that, unlike before in our previous example where you're dividing it all by the sine degrees, when you break this apart and move just the sine on the bottom, you get what's called an inverse sign. And in your calculator, that might look something like this. It's also called arc sine here. So when we do that, I'm going to go ahead and write it out. You're going to get, normally, it could be written like 1 divided by our sine, and that's multiplied by our 0.5. The problem is if you try to divide your 0.5 by just sine, your calculator is going to freak out. You're going to get an error. So we can't do that. Instead, when you have this expression here, you're simply just going to replace this entire thing with our inverse sign here, the sine times, or to the -1/2, or -1. So if we did that, if we swap that out with this, you'll get sine, or inverse sine, times 0.5. Now, if you plug this into your calculator, this will work, and you should hopefully get a value that tells you that your theta is equal to 30 degrees. If you got something different, it could be your calculator is in radians mode instead of degrees mode. So it's always a good thing to check and make sure that it's in degrees mode. Otherwise, you might get something else. So we got our theta value is equal to 30 degrees now. So I'm going to go ahead and write that up here, just so it's out of our way. And now all that's left to solve for is our adjacent side. So I'll clear this out. So that was the only tricky part. And now all that's left to do is solve for our adjacent side A, and it's just easy, just like our previous example, following the same exact steps. So Solve it for the adjacent. We know we need something that uses an a. So up here we can either use the ka or the toa. And since we already know our opposite and our hypotenuse side, you can choose whichever one you want. It doesn't matter. It just determines which equation you use. So if I wanted to use the hypotenuse side, we'll go ahead and use our h. So using the equation that has an a and h, that looks like it's going to be our ka equation. So now we know our degrees. I'm going to go ahead and write this out. So cosine of 30 degrees is equal to our adjacent side, which is our unknown value, so a. We're going to divide that by our hypotenuse, h, which is 6. All right, so this looks a lot easier. And to get our a by itself, we just need to multiply both sides by our 6 to bring it over here. If you did that, you get 6 times cosine of 30 degrees. And that would be equal to our a. And you would just need to plug this in your calculator, and that should give you your value for a. And if we did that, find that our a equals 5.2. All right, looking at that previous example, that's what we got for our a as well. And we also got our degrees was 30 degrees. Okay, so it looks like this problem is done. If you have any questions, please feel free to leave a comment. Don't forget to like, subscribe, and we're going to move on to our next topic, which is how to solve for non-right triangles. So see you in the next video. Thank you.